Okay, let's start. Let's start. Today from the beginning, I'm going to start Bose notation practices. Then here Bose notation we used to find stresses in light rods, no? Stresses in light rods. So I'll revise you again. You consider a diagram like this. I'll give you. Sketch this diagram with me. Take this figure. Here wall, 2 rods, inclination 45. Here downward force given 500 Newton force. Take here A, B and C. A, B and C. Okay, that's the system. Here these 2 light rods, here weight 500 Newton weight. So let's say we need to find stress. See the process now. I have given important steps, no? Step number 1, I told you to mark a boundary line around the figure, no? Mark a boundary line. Here this is a wall, no? This is a wall. Then you sketch boundary like this. No need to consider about wall, no? Then you neglect it and the other part you sketch a boundary line. Thereafter you produce external forces to cut that boundary line. Produce this to cut this boundary line. Then thereafter identify regions. Now. Here take A, take B, take C. Here are the regions. We have 3 different regions. So this is another important step. Usually we consider simple A, B, C letters to denote regions. You can consider 1, 2, 3, whatever it is, okay. But usually we consider simple A, B, C letters. Then vertices we denote by capital A, B, C. Okay. Then thereafter you have to select a vertex. Here I'm going to select this vertex. So here we have 2 unknowns. This is known, 3 forces, 1 known, 2 unknowns. 3 forces, 1 known, 2 unknowns. Then you select this vertex and go around it. Now here 500 force represented by AB region. Here AB region, 500 force represented by AB region. Then BC, by the BC region represent AC rod stress. Then BC rod stress represented by AC regions. So see how this sketch, okay? A to B 500 Newton downward. Say you go around it anticlockwise sense. A to B 500 Newton downward. B to C. Then B to C, here inclination only? No. 45 degree inclination. Then thereafter C to A, horizontal one, no? Here we don't know exact magnitude and direction. Here also we don't know exact magnitude direction, but here we know exact magnitude and direction. Then this thing we have to sketch now. Then consider here A to B downward 500. You sketch this way. Then A to B downward mean you take A here, B here. When you go A to B, then we can move downward, no? When you move A to B, we can move downward. Then AB magnitude you take as 500 Newton. AB length you take as 500 Newton. AB equal 500. Then go further. B to C 45 with this inclination, no? Then we know B, sketch 45 inclination line. Here 45 inclination line. Then C to A, we get horizontal one. A we know, sketch horizontal line. Then common point will be C, no? So here we call stress diagram. Okay. Then today we need to practice how to sketch stress diagram and how to identify stresses using Bose notation. That is the thing. Okay, let's practice one by one from the beginning now. Then the major steps, first step, you have to mark all external forces. Then second step, you better to find external forces if it is necessary. That is second step. Then third step, you mark a boundary line around this figure, then produce external force to cut it, and then identify regions and label them. Then select one vertex, so that vertex must be with two unknowns. Here we have two unknowns, then we have only one vertex now, then we can select exactly this one. But when we consider system of rods, we have to select proper vertex. We have to select proper vertex, okay? Okay, then start it now, start it. Don't just draw, okay? You practice this. A to B, you put finger at this vertex C and go around it. A to B 500. Then B to C incline. C to A horizontal. Then get common one. Likewise, you have to practice. You have to practice. Do up to that. Do alone. Okay. Now see next step. So here I have written in words here. You have to do it in your mind, okay? Now select this vertex, go around it. Same sense, okay? Until you complete the question, you have to go one sense. You have to consider only one sense, okay? Then B to C. B to C. Here we have to move B to C now. Then you go to this figure, stretch diagram. Move B to C. Then here B, here C. You have to move this way, no? You have to move this way. Then selected vertex, you have to move this way, no? Then you put that direction. That direction. Then C to A, C to A. Take C here, A here, then C to A here, this way, no? This way. Then move C to A, this way. Then selected vertex, you mark that direction. You have to select a vertex first, okay? Then the other corner, you mark opposite one. Here, you mark opposite one. Then here we say this is tension, this is thrust, no? So we usually we know, here this is tension and here thrust. Tension and thrust. Now we have identified tension and thrust, no? Then now get a table. We have to find stresses now. Then here the table, rod, stress, stresses and magnitude. You have to practice well. Then here tension and thrust. Now here magnitude in newtons now. Then we have two rods BC and AC. Clearly see BC and AC. Then already we have identified AC has tension. BC has thrust now. BC has thrust. Then tension and thrust. Further, BC rod. Here BC rod represented by AC regions now. BC rod represented by AC region, separator region. AC rod represented by BC region. Then here this length represents its magnitude. Then here AB 500 no. Then 90 degree here 45 no. Then if this one 500, then we have 45 degree. This will be 500 again no. Then 500 here. This will be 500 root 2 no. No, don't write here, but you can identify that no. Then AC length 500. Then here BC length, it is 500 root 2. That's how we identify stresses. This is we call Bose notation. This technique we call Bose notation. Okay, complete it now. Don't just do, you need to practice this. Huh? You have to practice how to sketch this figure, stress diagram, and you have to practice how to mark these stresses. And thereafter you have to practice how to obtain here these magnitudes. Okay, we have 3 major steps. Okay, complete it now. Okay, now let's move to another question. Now I'll give you a step, you do. Here take this diagram. Here horizontal line, 60 degree inclination. Here A, B, C. Here take 300 Newton. Okay, first sketch this diagram. Sketch it. Okay, now you do with me. First you identify the figure. Here rod, here force, here wall, no? Wall. Then we have to find stresses in the rod, no? Therefore, we have only one vertex to do that. Rod mean a force. Rod has stress, no? Then rod mean a force. Then first you have to mark boundary line. You better to get this way, no? Here boundary. Okay, do with me now. Do with me steps. Then produce external force to cut it. We produce that because we need to identify regions. Then here we can identify different regions, no? Then you can label them. No order here. You can just label. Do up to that. Do alone. Okay, now we have to select only one vertex now. We have only one vertex. Here take this vertex. Then you put finger here and select that vertex and go around it. Until you complete the section, you go around it. So I'm going to go clockwise, anti-clockwise sense. Then first thing, you better to cut non-force, okay? You better to cross non-one, this way. Then A to B, downward 300. You mark it. Here A to B now downward. A to B downward 300. Then AB length you can take as 300, no? 300. Then BC horizontal, no? BC horizontal. You sketch horizontal line. Then C on this line. C on this line, remember it. Then C to A, here this says 60 inclination to the horizontal. Here A we know, then sketch 60 degree inclination to the horizontal. So on this line C, the intercept will be C. Intercept will be C, no? So that's how we sketch the stress diagram. This is stress diagram that represent forces, no? Okay, continue. Same time you better to get table, rod, stresses, tension, thrust, and magnitude. Now rod AB and BC. Then by side you better write AB rod represent by AC region. BC represent by BC again. Separated regions BC, no? Okay, do with me properly. So when you select in a vertex, you better to put finger and go around it close to that. Okay, now let's mark forces now. Do same thing. Then select this vertex, same sense. B to C. We go B to C now. Then B is here, C is here. Then B to C motion this way, no? B to C motion this way. Then at this vertex, you mark that direction. Then C to A. Here C is here, A is here. C to A this way. Like this. Selected vertex, you mark forces. Then the other corner mark opposite direction. Here it is. Then identify this is tension and this is thrust. Then BC has tension and AB has thrust. Then magnitude you can obtain by this triangle, no? Then if we have a triangle, to find sides, we better to get sine rule. Then apply sine rule, or other geometry you can consider. AB divided by sine 60, BC divided by sine 30, AC divided by sine 90. Then AB 300, sine 60 root 3 over 2, BC sine 30 half, AC sine 90 1. Then you find BC equal 300 over root 3. We can simplify this, 100 root 3, no? Then similarly AC equals 600 over root 3. Then that is 200 over root 3. 200 root 3, no? Then AB, BC length 100 root 3. Here 200 root 3. So that's how we identify stresses, no? Continue. Okay. After that you go to this figure and you start doing everything. I'll give you 1-2 minutes to start it. We have to find stresses. You mark boundary, then produce force to cut that boundary. Don't produce the other way. We better to produce this way. Then label regions A, B, C. Here this is a flow, no? Then no need to think about what will happen here and here. But definitely there will be reactions, no? There will be reactions according to symmetrical thing. Then you can say here R and here R. So we can find them, no? By symmetry, by considering vertical equilibrium. This is not compulsory, okay? 2R equal 200 Newton, then R equal 100 Newton. This is not compulsory. Okay, we can neglect it and we can find here, when you consider this vertex, we have two unknowns, no? Then without finding other external forces, we can continue it. Okay, now you select this vertex. First you cross known force, go anticlockwise sense, C to A 200 downward. Here C, A. Then AC 200. AB to the vertical 30. AB to the vertical 30. Then you remember B on this line. Then B to C to the vertical 30 again here in this inclination. You sketch same rod, okay? From here you sketch that. And that also to the vertical 30. Then B on this line, finally common point will be B. Okay? Now same time you mark forces, go around it, A to B. Here A to B this way, B to C this way. Then the other corners mark opposite directions. Then here these two trusses, no? Truss. Then AC 200, no? These two same, no? Then take here, you can apply sine rule, let's say, or you can resolve it. Then AC 200, no? Then 200, AB cos 30, BC cos 30. Take here this length P, P cos 30 times 2, no? This is also P. Then 200 P cos 30, root 3 over 2 times 2. Then P equal 200 over root 3. That means AB length, BC length equal 200 over root 3. 200 over root 3. Now finally, we have identified stresses. Now we better represent it. Take table, rod, stress, stresses, magnitude. Tension, thrust. Then we have two rods AB and AC. Then here thrust. AB rod represented by AB region. AC rod represented by BC region. BC. Then we know same value, no? 200 over root 3. 200 over root 3. That is Newtons. Complete. Don't just sketch. You have to practice. Just think and do. Okay, now you try alone. Here 30 degree, 300 Newton. A, B, C, like first one. Okay. Okay, you try it. Try it. Okay, try alone. Now, if you have doubt, do with me. Sketch boundary line, produce this force, and label regions A, B, C. Then select this vertex and go around it. First step, you better to cross non-force. Okay. Then non-force 300. A to B 300 downward. Then here A, B. B to C to the horizontal 30. B to C to the horizontal 30. C to A horizontal. Here C to A horizontal. Then here AB 300, no? 300. Then same time you better to mark forces. Again select this vertex and go same sense around that vertex. B to C. Here B to C this way. You mark arrow. C to A. C to A here this way. You mark arrow. Then the other corner opposite directions. Then to find stresses, we better to consider sine rule, no? Then AB over sine 30. AC over sine 60. BC over sine 90. Then AB 300. Sine 30 half. AC sine 6 root 3 over 2. BC sine 91. Sine rule very strong operation. At once you can find 2. And or otherwise you can consider any geometry to find sides. No? You can consider any geometry. But here sine rule is the best. Then AC equal 300 root 3. Then BC equal 600. BC equal 600. Okay. Then rod stresses and magnitude. So that is in newtons, here tension and here thrust. Then we have true rods AB and AC, BC. Then AB thrust, BC tension. Then AB represented by AC, BC represented by same BC. No? Then here AC 300 root 3 and BC 600. 600. Okay. Those are the values. Complete. Okay. Now let's increase the number of rods. So previously we had only 2 rods now. Now see this diagram, we have 1, 2, 3, 4 rods. Okay, sketch that diagram and let's start it. You better do with me. First sketch diagram. So we need table here now. I'll put it here. Rods, stresses, tension or thrust, magnitude in newtons. So AB rod, BC rod, AC rod, DC rod. Okay. Now we have to do very carefully. First step, we have to mark a boundary line. No? So here we have a wall. No? Then no need to consider about wall. We have to find stresses on the rod. No? In the rod. Then we better to consider here this type of region, including vertex B and including vertex C. We can neglect A and D. So when we neglect it, we neglect because here that contain a wall. No? Now produce this and identify different regions and label them. Okay, start doing with me. A, B, C, D. For this we don't have any order. We can do whatever we think. Okay, mark regions. Continue. Okay. Then you analyze this. So we know when we consider a vertex, when you have 2 unknowns, then only we can complete finding unknowns. No? When we have only 2 unknowns, we can resolve horizontally and vertical, then we can find unknowns. No? Then when you consider this vertex, we have 2 unknowns, 1 known, then we can complete it. No? But when you select this vertex, we have 3 unknowns. At the beginning we have 3 unknowns. No? Then we can't find. Then Bose notation work only for this vertex first. No? Because we have 2 unknowns, 1 known. Then we can go to that. Then you select this vertex. You try to complete it. Okay, you try. Start sketching figure, stress diagram. Select vertex B and try to sketch it. Select this vertex, put finger, go around it, cross known one, then A to B 100 downward. Here AB 100 downward, by the side write down AB equal 100. Then BC, here this way inclination 45, sketch 45 inclination line, C on this line, CA horizontal, A is here, then C is here. 45 degree. Then same time you mark forces B to C, here this way, C to A, here this way. Then opposite corners you mark opposite direction force. Same time you update the table. AB has thrust, BC has tension. Then AB rod represented by AC, BC rod represented by BC. Then same time you better to find values, no? Then AB 100, then 45 degree mean here these two sides must be same, no? Because this is 90. Then AC equal 100 again. Here these two same, no? Then BC equal 100, 100, here 100 root 2. Then update table, AC length 100, BC length 100 root 2. Then we have completed that. Thereafter, you go to other vertex, here this one. Now we know BC rod. Now go around it. Then here B to D horizontal line. Then you sketch horizontal line. Remember D on this line. D to C, here this way inclination, C is there. Then 45 degree inclination. So here this must be D, no? Then B to D horizontal one, D to C to the horizontal 45. Okay. Now same time mark forces. B to D, go B to D here, B to D here this way. D C here this way. Then opposite directions. Then here AC rod. AC rod is its thrust. So here DC. DC rod, it is tension. So DC rod represented by BD, no? Here this region BD. Then here 45 degree, here 90 degree. Then BC. BC and DC same. 100 root 2 and BD length. Here 100 root 2, 100 root 2, no? Then multiply root 2. Then here 200, no? So the order we take here AA root 2A, like that, no? AA root 2A. Okay. Now update this table. DC 100 root 2 and BD 200. Okay. That's how we get it. Okay, complete. Don't just sketch. You do it step by step. Huh? I'll give you one and another. Take this. Here floor. Here 45-degree inclination. Horizontal line. Here to the horizontal 30. Say A, B, C, D at C. Give 100 Newton force. Here 90, 90. Here 30. Okay, start it now. Start it. Take your time. This is horizontal line, okay? Now let's mark boundary line. Here this is flown, we have to neglect it. Then we can start like this boundary line. Or we can select like this. Then produce this force, identify regions A, here B, here C, D. We don't have any order. Continue. Do alone. Analyze properly. Yeah? Analyze properly. Always you have to select a vertex with two unknowns. Then only we can complete sketching stage diagram. No? Then here we have specially two vertices. Then we better to select C. We have two unknowns, one known. Then you go to B. Then we can find the others. No? Okay. Now continue. Do alone. Okay. Now you select vertex C first, go around it, then go to vertex B, go around it. Start doing. Okay. Table, rods, stresses, tension, thrust, magnitude, newtons, then CD rod, BC rod, BD rod, AB rod. Then CD rod represented by AC, BC rod represented by BC, BD rod represented by DC, AD rod, AB, no? AB rod represented by BD. Okay. Now I told you to select a vertex with two unknowns. No? Then you select C, better to put finger here, and first you cross it, take 1 sense. AB 100 down, sketch it here AB, BC horizontal, CA here this way to the horizontal 30, and this will be C, no? You sketch this figure by pencil only. And because we have to correct sometimes. Then when you sketching the figure, you have to think about scale. Okay, angle 30, here 30, don't sketch like 60. Okay, you better think about scale. Then go to, same time you mark forces B to C. Here B to C, this way, C to A, here this way. Then the other corners mark opposite directions. Then same time you better to update the table CD thrust, BC tension. Then here same time better to find forces. Here AB equal 100 no. Then 100 AB over sine 30. BC over sine 60. AC over sine 90. Then AB 100, sine 30 half, BC sine 60 root 3 over 2, AC sine 91. BC equal 100 root 3. AC equal 200. AC equal 200. Then AC 200, BC 100 root 3. Then go to next vertex B, go around it, put this finger and BT to the horizontal 45. B is here, sketch to the horizontal 45 line. Then CD vertical, C is here, this will be D, vertical line. 45-degree inclination, then that is easy to find. Then BD, here BD direction, DC upward. Then other corners opposite. Okay. Then BD thrust, AB tension. Then BC with 45 here no? Then DC same, BC DC same. DC value 100 root 3. Here DC value 100 root 3. BD, here when you consider here x here x root 2 no? Then here BC mean 100 root 3. Then BD you can write 100 root 3 times root 2. That means 100 root 6. 100 root 6. Practice properly. Here when you consider right angle triangle with 45-degree inclination, here this will be A, this will be A, this will be root 2A. So by that order we can easily find 45-degree cases. No? Complete. Okay, then you come to this diagram. So same diagram I have given, but here different angles. Okay, previously I gave 45 degree, now different angle. Okay, start it. Take time. Okay, let's see. Take boundary, produce force, label regions A, B, C, D. Select this vertex and sketch for stress diagram AB 500 down, BC to the horizontal 60, CA horizontal. Then go to this vertex, same time better to mark forces. BC here this way, CA here this way. BD, go to this vertex, BD horizontal, sketch horizontal line, DC 60 degree. This will be D, no? Then mark forces, BD here this way, DC here this way. Then consider AB 500, no? Consider ABC triangle, AB over sine 60, AC over sine 30, BC over sine 90. Then AB 500, root 3 over 2, AC sine 30 half, BC sine 91. Then by this find AC 500 over root 3, BC 1000 over root 3. 1000 over root 3, no? Then here BC, DC, BD same, no? BC, DC, BC, DC, BD same. Okay. Now see the table. Rods, stresses, tension and thrust, magnitude in Newton. So AB rod, BC rod, AC rod, DC rod. AB rod thrust, BC rod tension, AC rod thrust, DC rod tension. AB rod represented by AC, BC rod represented by again BC, AC rod represented by CD, DC rod represented by BD. Now put the values. Yes, AC. AC 500 over root 3. BC 1000 over root 3. Then all the others same, no? 1000 over root 3. 1000 over root 3. Boss notation, very simple question. So definitely you will get maximum 9 mark, okay. Minimum 8, but maximum 9 out of 100 for applied. Okay, complete it. Okay, then you come to this figure, take this figure and you try. Okay, here one important step you have to mark all the external forces. So here the system on 2 pegs, symmetrical system, no? Then we have to mark reactions here and here. I'll do that and you complete the question. Here take R symmetrical, no? Then 500 will be distributed, no? 250, 250, 250. Okay, now you start it, take time. Okay, now let's take a boundary around this full figure and produce. When you produce a force, don't cut a rod, okay? You produce into one direction, along one direction, okay? Don't cut a rod. Then you better to produce opposite direction. And label here A, B, C, D. You can select one vertex, no? One vertex. So that contain only 2 unknowns. Then here 2 unknown, 1 known, 2 unknown, 1 known, 2 unknown, 1 known. Then you can select any vertex. So I'll take this. AB 250 upward, sketch it. Anticlockwise sense. AB 250. BD to the horizontal 60. To the horizontal 60, DA horizontal. Here A, then this will be D, no? Same time mark forces go same sense. BD here this way, DA here this way. Then go to this vertex, DC, /60 inclination, here CA 250, here CA. Then DC, here this way, truss tension, okay. Then here 60 now. Then consider ABD triangle, AB over sin 60, AD over sin 30, BD over sin 90. AB 250 now, sin 60 root 3 over 2, AD sin 30 half, BD sin 91. Then AD 250 over root 3, BD 500 over root 3. Then CD equal BD, then we can complete the table now. You get the table now. Rod, stresses, tension, truss, magnitude in newtons, AB rod, AC rod and BC rod. AB rod truss, AC rod truss, BC rod tension, AB separated by DC, AC separated by BD, BC separated by AD. Then AD 250 over root 3, here 500 over root 3, 500 over root 3. Complete it. Okay, then you take this figure, 90 degree, 90 degree, 45, 45, 45 inclinations. 100 Newton has suspended, no? Okay, start it. Okay. Now you better to get boundary line like this. So we take like this now. Then it passes through E. It passes through A, mean we can neglect vertex A and vertex E. Then here EA wall now, then we can neglect it. Then produce A, B, C, D, E, F. Same time, let's get a table. Rods, stresses, tension, thrust, magnitude. Then you think now we can start from here now. You can start from here, then you better to get BC and DC rod first. BC, DC first. BC, DC first. Then we can go to B now. Then take BD, AB. Then you can go to here now. Then ED, AD. Likewise, we better to get that order. Okay. First we go to this vertex now. Then select DC and BC. Then we can go to B vertex. Then you select DB, AB. Then we can go to this vertex. ED, AD. No. Then here BC given by BD, no? DC given by DC again. BD given by ED. AB given by AE. ED given by CF. AD given by EF. Okay. You have to practice, huh? Now let's test diagram. You go to vertex C and put finger and go around it. See, BC 100. BC. And also, we better to cross all known forces. Better to cross all known forces. Then usually I told you, we better to select two unknown vertex, no? Then before that, we better get AB first. Select this vertex, go AB. AB 100. Then go to next vertex, don't complete this one, go to this one, BC 100. Now all known forces there. Now complete this. CD horizontal, DB, this way inclination 45. 45 degree, that is D, no? Then same time mark forces CD, DB, then you go to this vertex, BE, DE, DE, we need space, no? I'll sketch it again. Okay, see this? AB 100, BC 100, CD horizontal, DB 45. Then go to this vertex, DE 45, EA horizontal. Then go to this vertex, CF horizontal, FE 45. Yeah, F. Then mark forces here, go to vertex this, DE, here this way, EA, here this way, then CF this way, FE, here this way. Now the forces are okay, no? Then same time you update the table. DC, before that BC thrust, DC tension, BD tension, AB thrust, ED thrust, AD tension. Then find values, BD. Here BC 100, no? Then this will be 100, this will be 100 root 2, here another 100, no? Then DE, here 45, DE sin 45 200. Here DE resolve sin 45. Then DE equal 200 root 2. DE 200 root 2. Then this is 200 root 2. Here 90, no? Then EF 200 root 2. 200 root 2, then you put here 400. AE, see, 200 root 2 cos 45, 200 plus 100, 300. 300, no? Usually we don't mark magnitude here and we don't mark arrows here for stress diagram. Usually we don't mark. Then update table BD length, yes BD, 100 root 2. DC, it is 100. ED 200 root 2. AE, that's AE 300. CF, total one, no? 400, 100, 500. EF 200 root 2, no? That is it. Complete. So these things you practice again and again. Okay. Then you take this figure and try it. See this figure and try it. Horizontal line, then others are inclined 60 degrees. 60 degrees. Take time. Okay. Take this boundary. Reduce. Label regions. Better to cross all known forces. One sense. AB 100 downward. BC 100 downward. Then go around this. CD to the horizontal 60. DB horizontal. Same time mark forces here. CD, DB, then go to this vertex, CE horizontal, ED to the horizontal 60. Same time mark forces, CE here this way, ED here this way, CE, ED. Then go to this vertex, EF to the horizontal 60, FA horizontal. Same time mark forces, EF here this way, FA here this way. Select that vertex, put your finger there and select that vertex and go around it. Go around it. Okay. Now you have identified the type of forces, then you can find the values. No? Then consider ABC triangle first. BC over sine 60. BD over sine 30. CD over sine 90. Then BC equal 100, no? Root 3 over 2. Then BD sine 30 half CD. BD equal 100 over root 3. CD equal 200 over root 3. Then here equilateral triangle BC DC, no? DC equal EC equals DE. Then here EF sine 60, EF sine 60, 100, 100, 200, root 3 over 2, 200, EF 400 over root 3, EF. Then we need AF, no? AF equal EC plus EF cos 60. Use geometry. EC 200 over root 3. EF 400 over root 3. Cos 60 half. Then final value 400 over root 3. Now we can fill the table. No? Then you fill the table. Tension, trust, trust, tension, tension. Fill the table. Rods, stresses, tension, trust, magnitude in Newton, BC, DC, BD, ED, BE, AB. BC thrust, DC tension, BD thrust, ED tension, BE tension, AB thrust. BC represented by BD, DC represented by DC, BD represented by ED, ED represented by EC, BE represented by EF, AB represented by AF. Then complete. BD 100 over root 3, CD 200 over root 3, ED 200 over root 3, EC again 200 over root 3, EF 400 over root 3, AB, that means AF 400 over root 3. Complete it. Then you come to this figure. Here a hinge and here a peg. So you can go to this vertex and here 2 unknown, 1 known, we can complete it. Thereafter you can go to this, you can find these two now. Thereafter you can go to this, then you can find it. Then you better to mark reaction R. Then without finding R we can complete. Okay, without finding R we can complete it. Okay, here hinge no. Then we better to get boundary like this. So if there's a hinge, we better neglect it. Then we better to take like this hinge now. We have two force component now. So if there's a hinge, we better to get boundary passing it. Okay. So when it passes through that hinge, then we can neglect all the forces. Otherwise, here we have horizontal and vertical component now. Otherwise, we have to mark it. Otherwise, we can neglect it. Now start without finding, we can go here. I told you one important step, mark all external forces and find if it is necessary. Then if it is necessary mean, if you go to this vertex, we can find these two. No? We have two unknown, no? Then we can go to this. Then by the order, we can complete all, we can find all the forces. Then without finding R, we can go another path. That's why I told you if it is necessary, we have to find. If it is necessary only. Okay, start it. Okay, see my works now. Now without finding R, we can proceed. By the Bose notation also we can find R. By the Bose notation we can find it. Okay. So see, reaction at A also we can find same way. Reaction at A. Check it. Now here if you need to find reaction at A using Bose notation, you better to mark reaction here xi component is a hinge no need to put directions. So by Bose notation we can find that. So in such case you better to get bounded like this. You mark reaction component x and y like this and you better take bounded like this. Then by Bose notation we can find that reactions if you get that way. But usually we need to find stresses in each rod. Stresses in each rod. Okay. Now I'll take here A, B, C, D, E. So if you need to do that way, then take this region F. Then we have to increase one region. Then go to this vertex, complete B, C downward 500, CD horizontal, DB 60. Then go to this vertex, CE 60, ED vertical. Then go to this vertex, EA horizontal, AB vertical. Like that. So if you get F here, then we can follow this. Then take this vertex, EC, CF horizontal, FA vertical. Then here this will be coincident if you get that region. Okay. Now mark forces, CD, here this way, DB, here this way. Then go to this vertex, CE, here this way, ED, upward, EA, this way. Then CF, here CF horizontal, FA vertical. Here F not here, F is here. Okay. Then no horizontal component, FA we can take. Okay. Now 60-degree inclination, this is parallelogram, we can find easily. By sine rule we can find here the values and here the values and here the values we can easily find. No? Complete. Tension, trust. Let's find. No? BCD, triangle BC over sine 60, CD over sine 30, BD over sine 90. BC it is 500, root 3 over 2, CD, CD over half, BD, then CD, cancel 500 over root 2, root 3, then BD, 1000 over root 3, then DE, D equal BC, CE equal BD, EA equal CD, and every value is known, no? Then we can complete the table. Finally, you update the table. Rod, stresses, magnitude in newtons, tension, thrust. CD, BC, BD, AD, AB. Check it. CD, BC, BD, AB and AD. CD tension, BC thrust, BT thrust, AD tension, AB thrust. CD separated by CD, BC separated by BD, BD separated by ED, AD separated by EC, AB, SAB separated by AE. Then if you need to find R given by AB, here by AB we can find R, no? Then by Bose notation we can find external forces as well. Then CD 500 over root 3, BD 1000 over root 3 ED, yes, ED, ED, it is 500. EC is equal BD, 1000 over root 3, AE, 500 over root 3, 500 over root 3. Those are the values, now. Okay. Now later you better to do past paper questions. Start past paper question from 2024 and go backward. Then you can complete all the question. But anyway, next day I'll do another few questions, another few special questions with Boss notation part. Then we can complete for today.